we're talking about the cloud technologies and how they affect the edge and what role they play. So what's so great about the cloud? We're going to try to answer that question. And then we're going to talk about what the edge is. And then we're going to talk about what we've learned at Foundries and what we can maybe learn from the broader ecosystem. And then we're going to talk about Foundries Factory, which is kind of our solution to this for the edge and IoT products. So as we're going along, feel free to ask any questions in the chat. I can either stop if we have a bunch of questions as I'm going through the slides and try to address them, or we can do it at the end. So feel free to just throw them in there, and as we go along here, we can kind of see where the interest is. So let's get started. We do some general housekeeping here. So this is, you can submit comments in the chat. We have a bunch of Twitter posts that we're doing right now. And then obviously the slides will be provided as well at the end of this presentation. So if you miss it or you're watching this as a recording, you can grab those slides as needed. So what is so great about the cloud? That's probably what you're asking yourself. Well, they typically, the cloud, I'm generalizing this quite a bit, is they ship code to production every day. And if you think about edge and IoT, and maybe you have products right now, do you ship code every single day to the edge, to those devices? And the answer is probably you don't. And what does this mean? Well, it means that the latest software is being deployed continuously in the cloud. And the applications that they're building have minimal dependencies on the underlying hardware. And now there's a reason for that. Obviously, the cloud is usually one architecture, one processor architecture. So you don't have to worry about dealing with different architectures. And honestly, the cloud is commodity hardware. The hardware doesn't really matter. You basically are provided a platform and the applications run on top of that underlying hardware. So what does this actually do? Well, it allows the developers to quickly test, debug, deploy new functionality, new features, new applications very quickly. Something that the edge and IoT space needs really badly, but isn't done in practice every day. So they develop pipelines to deliver production code, and it's all automated. And they rely on a lot of automation to provide that. So for testing purposes, for deployment purposes, all of that stuff is automated. What does that mean in the end? Well, it means that they can respond quicker to security issues, new user features, or really anything. Adding applications as needed. They're much more responsive than maybe a typical embedded developer would be, or embedded product. So what does this actually look like? So this is a picture. This is not my picture. I found this on a presentation, but I think it actually describes, cloud native DevOps. So you probably heard that before. I'm going to try to define it. So it basically means developers push code, and when they push code, there is a build and test phase. Once that completes, it publishes whatever artifact that is. Now, in this case, this is a container registry, so this is an OCI container. And then the application or the deployment actually, will synchronize and pull those new produced images in, and boom, the app on the cloud side is updated. And then on the other side, there's an operation sides where you have like a stateful repository, maybe some configuration data, and that also needs to be synced. So it's all driven typically through code. So in this case, GitOps. So we push with Git, and things happen to the app on the other side of the deployment. And really, this is something that they've been developing for years, and this allows them to move faster and accelerate development by using CI/CD with GitOps. And so we think this is actually a really good approach. But the question is, there's a lot more complexity with embedded that we can't just mask over because we have different architectures and we have different hardware. And we'll get into that in a second. But this is what cloud native DevOps means, at least to me, and I think this is an accurate representation of that. So developers. Modernized cloud workflows attract new developers. You have college age folks coming into the workforce, and they've been trained on these modern technologies. How to build apps in the cloud using container runtimes, using virtualization. All of these things, they're coming out of colleges with that skill set. And so again, cloud native DevOps allows you to ship the software faster because of the processes, because it's an automated pipeline to production. And again, this all comes down to security, right? If you're able to get the latest code out, whether that's dependencies that you rely on that has a critical vulnerability, or it's your actual application code, it doesn't really matter. It can be delivered much faster, and you can be more responsive. So that's a really good practice, and I want to highlight that. There's also a lot more cloud developers than there are embedded IoT and edge developers. We're an aging group. I feel like I'm maybe a little bit younger, but I'm aging myself, and bringing more embedded edge developers in is going to be difficult because all of the cool stuff is in the cloud. So what I'm trying to get at here is that we need to kind of modernize our approach to attract more developers to embedded and IoT and edge platforms, and we can do that by embracing some of the processes that are already out there that these companies use. So that's the gist of why I think the cloud native DevOps is a good strategy. Now, there's a lot to deal with on embedded systems, particularly to make this work properly. So let's explore that a little bit. So what is the edge? Well, the edge is embedded. It's IoT. It's constrained, resource constrained devices. It's custom hardware. So operating systems are tightly coupled to the applications. That's the way we've been building embedded systems for the last 30 years. And that's because everything has to be optimized. And there's a reason for it. And that's how we've done it. But I think times are changing, and over-the-air updates, they don't happen on embedded systems. Rarely that they do, and they're kind of painful to deal with. They're pain for the users. They're pain for the customers or the producers of the product. And typically what happens here is you take a vendor BSP for the SoC, you customize it for your hardware, and you ship it and you forget about it. And that's worked for the last 30 years. But I think as we're starting to see, the different attacks from different nation states, this is going to have to come to a head, and that's not going to be acceptable anymore. And so we need to start thinking about how we can get into this more cloud native DevOps processes for edge and IoT and embedded. Again, the hardware is very custom and it's not commodity. And we're dealing with multiple architectures a lot of times. And so there's a lot of software challenges there to deal with. And that's why we can't just wholesale adopt the cloud tools the way they are. And then, of course, going back to updates, shipping the latest software is difficult on one-off hardware because chances are you've taken a vendor BSP, you've done your customization, and if you were need to move to a new version of that BSP, you'd have to redo all of that work each single time, and then you'd have to obviously have an over-the-air update mechanism to update that, which includes boot firmware, and if you're using OptE or ATF, all of that stuff has to be updated as well, and that's very, very difficult to design and implement that solution. The other thing that's a problem is platform security is basically non-existent. We see this with our customers. They to the extent of they've never thought about doing secure boot, or some of them have secure boot, but they have the keys sitting in plain text on the file system, so it's not all that secure. But it kind of varies, but real platform security is very much lacking in the industry as a whole, and I think it's very important that we look at ways of securing the platforms, because if we want to treat them like commodity platforms, they have to be secure, and I think that's the ultimate goal of cloud native DevOps on the edge. And the big problem is that every company builds and maintains their own stack, and they look at it as a value add, that they've created their own distribution, they've customized their own distribution, they've customized their Linux kernel and U-boot, and that's all value add. Whereas that's just a lot of work to build a product that is value add, and I would argue that none of that is value add. Your value add is how you differentiate yourself from your competitors and the value that you bring your customers. And none of that. I've never heard a customer say, "Wow, that operating system is excellent, and I would love to use that for something else." No, they never say that. It's the end application that they end up interacting with, and that really differentiates your offering. So what's the edge look like? So we have the cloud. Obviously, that's part of it. And then we have these things called edge nodes. And typically, they're the same architecture, and they're maybe scaled down data centers that sit on the edge. But really what we're talking about here is these edge devices here at the bottom. These are multiple architectures. These are custom pieces of hardware. Nothing runs the same software at this layer. And so to think about trying to update these or to implement these cloud DevOps practices, it's not going to work. Everything needs to be done differently. You'd have to have pipelines specifically for each individual product, and that's just not going to scale. So this is the problem that we're facing right now, is it's not commodity hardware, but we want to treat it like commodity hardware. So we're going to try a live poll here, and if we don't have a poll pop up for you here in a second, go ahead and just put your answers in the chat and we'll come back to it. But here we go. Look at this. So the question is, have you adopted a cloud native DevOps practices in your workflow? So that might be an automated pipeline for delivery. That might be CI/CD testing before you do it, or that's over-the-air updates, or maybe it's the whole thing. So if you could do a poll, and we'll take a look here. Oop, looks like we're pretty even all the way through here. So we have the majority at this point. Oh, we're going to split it right down the middle, aren't we? Give it a few seconds here. Good. Okay, so that's great. Yes is the answer. So 40% of the people on this call do it, and obviously you're here because you're interested in you know, how you might use that better or what other options there are out there, and that's really great. I think you know, if you're not on that scale, you're here to maybe learn about maybe why it could be interesting to you. But yeah, there's a fair bit of people that are in the know and potentially in the future, so that's good to see. So let's talk about maybe what we can do here. I'm going to go ahead and close this pull down here. So again, coming back to commodity hardware, if we could treat edge devices like commodity hardware, obviously we could inherit better security practices because we can deliver the software faster, and we can acquire a wider pool of developers. This is going to be key in the future because it's going to be harder and harder to find embedded developers to do this work because you have the large companies sucking up all of the talented resources, and then kind of the smaller companies are left to try to pick up the pieces there. And so to be able to scale, you know, edge IoT development, we're going to need a new pool of developers that currently don't work on these products today. We want to accelerate the speed at which software is deployed to the edge. This is going to be critical. I would really like to see us as an industry adopt this before government regulation steps in and tells us how to do this, because I think that's coming in one way or another if we don't do this. And so we need to kind of show best practices, and as an industry, say, hey, we're preparing for the future. We understand that security is a problem, and there's no you know, there's no fix for security. There's the only way to be secure in our mind at Foundries is to run the latest software. That's the most secure software we know at the time to run. It's difficult to do on embedded edge and IoT products. So we believe that there are tools out there that can help you achieve that. But it's something that you know, takes a little bit of a paradigm shift from the way we've been doing embedded for many years. The other thing we can learn, and I think this is the big point, is decoupling the applications from the operating system is going to enable developers to deliver independently of each other. If you've worked on a product before, you've usually got a platform team, you've got an application team, and there's a big integration window, and then there's a big QA you know, feedback loop, and that they just iterate on that. And the problem is that the platform team has dependencies into the application, and so they have to kind of deliver in lockstep. If you can decouple that, I mean, obviously there's going to be coupling that happens at the kernel interfaces and things like that, but from like runtime dependency, you know, perspective, decoupling those applications and, you know, containerizing or virtualizing them isolates them a lot from the platform, and so you can start to begin to treat applications independently of the platform, the underlying platform. Although obviously there's still ties to the hardware, especially if you're using an accelerator like a GPU or an FPGA. You know, those things will have to still be coupled, but at least it's not the entire operating system and all of its dependencies. So it's a step in the right direction. And I think the other takeaway is modern problems that we're starting to face here, where we are having large scale cyber attacks, you know, ransomware attacks. These are modern problems. These are problems we didn't have 20 years ago. And so we need to look at these problems and see how we can address them with modern solutions. And that's what I'm going to talk about next. So let me just check and see if we've got any questions here. Okay, yep, we are recording. So if you have to leave early, you'll be able to pick this up afterwards. Okay, so what is our solution to this? So we call our product Foundry Factory. It is a cloud service that enables cloud-native DevOps workflows for secure, updatable IoT and edge products. So you get all this great platform security that I talked about earlier that you need. Maybe you don't have it today. Maybe you do have some of it. It'll still work either way, but we kind of give you a turnkey cloud service to build and deploy and manage and maintain these devices in the field. So I think the selling points here are it's built on open source software. So the code is open on GitHub. You're not locked in because we provide proprietary software. Secure by design. So I kind of say there's three tiers of security that we can help you with. So the first tier is you run on an SD card and maybe something like a Raspberry Pi. There's not really a way we can secure a Raspberry Pi. It doesn't have the hardware features. It doesn't have, the eMMC support that you would need to actually have some sort of secure storage system. You can bolt a TPM on it, but it doesn't really give you a true root of trust. And so, that tier one stuff we can definitely support, but we typically move customers away from those like prototyping platforms early in the design phase to move them to something that can be securable, and then can kind of graduate to tier 2 and tier 3, which I'll talk about in a second. So tier 2 is where the SoC provides secure features, so fusing capability, the ability to access RPMD, which is a replay protected memory block in the EMC, so it's a like secure storage inside the eMMC chip. Those are the basics of being able to chain the root of trust into the SoC, and then secure the boot chain up, so that when over-the-air images are applied, they're also verified and will not boot any other image unless it's signed by you, the customer. So that kind of works out of the box with Foundry Factory, and you get that without having to go and implement it yourself. I think that's a huge step into making platform security kind of the baseline of what we build with on embedded products. It also provides you with a GitOps native workflow. So all the actions that trigger things to happen in the cloud are triggered by Git actions. So when you push code, whether that's infrastructure as code, so we have a repository which allows you to define what your factory can do, and what targets it builds for, and a whole bunch of features that I unfortunately don't have time to get into, but it's there. And then also, as you push to platform repositories and container repositories, they create what we call targets, which are effectively builds that allow you to produce updates and then update devices to these targets. So in the end, it's a turnkey software as a service product that helps you take open source software and productize it into a secure, updatable IoT Edge or embedded product. And that's really the gist of what Foundry Factory provides. So what's our vision? And I kind of hit on some of these points, but I want to really nail it home. So this is hard to do, and this is why we think there's a lot of value in Foundry's Factory, is that the most secure software is the latest software, and it is hard to run the latest software on embedded devices for a number of reasons that I've already mentioned. But we want to deliver an open platform, a secure platform, and a platform that allows you as embedded IoT and edge developers to customize absolutely every bit of this, but not maintain the distro yourself, because no one wants to maintain a distro if they don't have to. We do that. We take on that pain for you, and we make it easy for you to update from one version of the distro to the next, with your changes being overlaid rather than forked. And I think that's the concept that is really key for what we're doing here, is it allows you to isolate your changes that you're making to the platform and easily move them forward over time. It makes it easier to maintain a product. It makes it easier to take updates, to test updates, and ideally, it makes it easier to deploy the latest software, which makes you more secure. So not only do you get the platform security, but you also have a mechanism to deliver latest software should you choose to do so. And if you don't choose to do so, at least it's an insurance policy that you can be testing the latest software. So if you have to move and you don't want to move, you have an option and you have a path forward. I've worked in sustaining teams before and worked closely with them. This hasn't ever happened that I've seen. So every time we have to move to some newer version, it's basically a ground up redo of all the work that we did before, and it's expensive for companies to do that. And there's not a whole lot of value, if they're just fixing a security bug for that. And so that's why we're seeing the industry kind of ignore that, because it's a hard problem to solve. So we think we have something here that can help ease those pains. We want to enable cross-industry adoption and really enable customer choice. We don't want to lock anybody in. We want to allow the customers to build on our platform and customize it to their needs and tailor it. I think that's really key in idea in embedded IoT and edges, that everything is still going to be different, and we understand that, but we can make some changes to the way we do things to treat it more like commodity hardware, but still have the customization. We're also trying to disrupt the status quo and unfragment this IoT market the way this is. And the way we plan to do it is using industry standards to build off of, so that there's no lock-in. And we use a fair business model. So we're not trying to, charge per device, royalties and bandwidth and all that fixed costs, right? Because anybody that's done budgeting, if you look at a fleet of devices that are based on royalties and, dynamic costs, it's very hard to know how much you're going to have to pay each month unless the costs are fixed. And so we think that's a fair business model, and that's kind of the way we've gone with this. So let's take a look at the horizontal platform and kind of maybe give some examples of where this is used throughout the industry. So on the desktop, you've got your Windows, and you've got desktop Linux. I don't think that's used a whole lot outside of developers, but Microsoft is kind of the king of desktop still. Apple's obviously taking a share of that. Server, so you've got things like Linux that runs on basically every server out there for the most part, and there's enterprise offerings from Red Hat. So if you want to build a data center or a service, there's lots of options there for people to provide you that commodity hardware and then that commodity operating system that just works with those other applications. And on the mobile side, to some extent, Android AOSP is filling that role. It's the platform that people take that's open source, that they build out their customizations on, and they ship their phones, which are their product, and their differentiation is in the changes. The hardware changes, the features, the camera, all of that stuff is the differentiators in that market. And if you look at IoT Edge, there really isn't a clear winner here. And everybody still seems to do whatever they want. They roll their own Linux, maybe they leverage an existing distribution and fork it to make their changes. It's still kind of the Wild West of development there. And so that's where we're trying to position Foundries and Foundry Factory to be the platform that we build off of. Even if you don't use Foundry Factory, there's a lot of great stuff. There's been some derivative operating system and distributions built off of our Linux micro platform, which is our open source platform that Foundry Factory builds off of, to build their own solutions on top of that. And we think that's great because it showcases the technology components in the stack that I'm going to talk about in a second here is starting to get wide industry adoption because of the way we've kind of structured this. So what is Foundry's Factory? Now, there's a lot of data here, so I'll try to break this down. But effectively, there's kind of three different parts. So the first part is the firmware and the LMP, as we call it, or the Linux micro platform. This is a Yocto-based distribution that we maintain on GitHub that integrates components. So again, secure by design. It's going to have your firmware, so it's going to be U-boot or UEFI, and we're going to maintain that in LMP in the open, OptE, and an optional hardware security element if that's something that you're interested in. So we have those pre-integrated, off-the-shelf, ready to go. Kernel options, so we maintain a kernel, we have a stable option, but we also have vendor LTSs as well. So if you want to run an NXP SoC, we have a solution there. If you want to run a Xilinx SoC, we have solutions there. We work with very widely with industry partners to make sure that their vendor BSPs work with our solution so that we can leverage maybe a starting point that a customer has already started with, and it's not that much work to kind of come to our platform. And then we have user space, so it's very, very minimal because we expect the customers to come in and dictate what's in and what's out of their distribution and do that easily. So we try not to enforce any extra bloat into the image and let our customers choose. So we have kind of a really minimal Docker runtime. We have a really minimal client that does the updating and that does the verification of the updates. And then we kind of get out of your way and we provide the next part of the solution, which is Foundry Factory Cloud Service. And this is where the cloud native DevOps, turnkey solution comes in. Is that you get, you can go onto our website, you sign up, it's free right now for 30 days. You click create a factory, you select the hardware platform that you want to start with, and in 20 minutes, you'll have a full platform build that you can flash onto your device, register, and start to manage that device. And as you push code, the device will just update with the new code once it's built and delivered to the device. So you kind of get all of that cloud native DevOps wrapped up in a simple to consume package that will work with your embedded devices and treat it, you can start to treat your hardware like commodity. So you get source code hosting, you get team management, so you can invite third parties in, like maybe you have some consultants that are going to help you with some drivers or things like that, and they need to be able to work on the source code. You can add them in, and you can set their permissions on what they can do and what they can't do. You can also obviously modify it just about anything. If you want to replace the kernel with your own kernel, you feel free to do that with your own recipe. And all of that customization and IP is then isolated so that it's then overlaid from next version of the LMP to the next, and it really makes it easy to upgrade. So we can also do testing. We provide a test framework, so you can define what tests you would like to run, and then as devices update, once they take the new update and it's complete, it will run the test for you and provide you with a report, so you can actually start to integrate testing into your cloud native DevOps processes. And then what's nice about this is it can be distributed all over the world, so there doesn't need to be a central board farm. It could be boards on developers' desks that are being updated and tests run on them, and then results collected. So it's very Foundry Factory is built to work with distributed teams, because here at Foundries we are completely 100% distributed, and we've been that way since the beginning. So we have to build the tools because we use our own tools internally to work with those workflows. And I think in this COVID era that we're in, and as we're starting to potentially come out of the pandemic, this tooling to work with distributed teams is a very valuable thing to have. So you can obviously add public-private cloud interfaces. So AWS, Google IoT, we have pre-integrated solutions for that run in containers that you can just deploy on your system and connect, and start publishing data. Really, the neat part is the security that you get. So we use OS tree, which is almost like Git for your file system. And so your update system doesn't need to have an A/B partition, and you don't have to divide your flash up. You can incrementally update the images as needed. So it's much more efficient from a bandwidth perspective, from a resource perspective. But then we secure it with this specification called TUF, which stands for the Update Framework, was developed by the Department of Defense to resist nation-state attacks. A very neat option. It's one of the only OTA frameworks we found that can mitigate just about any attack. Even if you lose your root key, you can rotate the keys in the field and recover targets. So it's a very neat project and a very awesome specification. So we think that this is something that will provide a lot of value to our customers. So we have fleet management as well. So it allows you to select a certain amount of devices and roll out updates, and then select another set of devices and roll them out. And so you can kind of stage your updates and do canary testing and all of that stuff. And so you kind of have all these tools to then manage these devices. Once you've created the updates and you've got your platform to where you want it, and you're going to ship a product, you have all of the tools that you need to do secure configuration management. So whether that's on a specific device or a fleet of devices, you can actually send out of band configuration to them, just like that cloud DevOps picture I think I showed on slide 3, where you've got the kind of code deployment and OTA update deployment side of things. You also have a way of configuring securely as well. All integrated. We also have secure remote access. So if you want to access any devices behind firewalls anywhere in the world, you can set up a WireGuard server that integrates with your factory, and you can have remote access to those devices. They basically call back home on demand. You can access them for a time being, and then you can turn that off. And we manage the distribution, as I said earlier. So we're patching CVEs and functional updates and bringing the latest software and all of the goodness from upstream in and integrating it into a nice way for our customers to consume, so they don't have to do that legwork. So what do you get out of a factory, right? You get everything. You get all the artifacts, the flashable artifacts. You get a pinned manifest, so that if you want to reproduce that build exactly, you will have all the hashes that are checked out so that nothing could change on you. You get CI/CD workflows right out of the box. So you get OTA updates signed securely for you and placed as targets for devices to update to. You get manufacturing tools in some cases for those platforms that have manufacturing tools, so that you can go through manufacturing of these hardware devices efficiently and be able to secure them. So being able to fuse them, being able to set the root of trust, being able to provision the keys securely. All of that stuff is provided as part of the factory as well. And then you get license management as well. So you get a manifest that has all of the different licenses out there, and GPL tarball, so that you can be compliant, and of course test results. One other thing too that we do is we allow you to look at the GPL v3 software that is in your build, and you can decide if that's something that you want to ship or not. It does have some legal ramifications on high secure devices that can be updated, and so we do have solutions there for those enterprise customers that are curious about the GPL v3 software and over-the-air updates. So that was Foundry Factory, and then really I think where this fits into product development is enables long-term maintenance, and it's much easier to do than what we've done previously, where we have to go back, say, oh, we need to change this software version, which has dependencies throughout the whole change, so this needs to be changed. If you think about Android, going from one version of Android to the next is quite a big lift for an engineering team. So this makes it a lot easier, Foundry Factory. So you reduce a lot of the engineering effort that's kind of wasted maintaining distributions and recipes and things like that. We do that for you, and we provide it as a platform. And really all you're focusing on as a user of this is your IP, what it does, your applications and drivers, value add, maybe it's FPGA accelerators, it's AI models, whatever it is, that's where you focus, instead of having to try to worry about doing your platform and how do I set up a test framework, how do I build all this software, then how do I update it, and how do I do boot firmware updates, right? We have solutions for these things, so we can kind of provide that to you out of the box. And again, this goes back to choice, right? We believe in choice because we don't want to lock anyone in. We want to be the standard that folks build on when they think of, okay, I've got to build a secure IoT product or an edge product. Foundries or the Linux micro platform is a good place to start because we're building on open source software and open specifications. There's influence that can happen. You can influence these projects. You can influence the standards to change them for your needs, and you're not locked in because if you don't like the service that you're getting, you have all the code and you have the specifications, and you can go and roll your own if that's what you'd like to do. So we're going to stop here. I think there was a few questions and answer some Q&A, and then we'll wrap this up. So let's see what we've got. We got 4
Tyler,
questions here.
I've got a few questions. If you want me to that makes it easier.
Yeah, that'd be great.
I can ask the questions for you. So questions come through asking, is there an initiative in the embedded space to push the containerization of devices?
I wouldn't say that there's something that is like an industry push. I think Docker has made a pretty good push. I think the OCI spec itself is a good place. Now, as far as getting them onto the edge, this is where I think the next 2 years of development is going to really focus on, is that optimizing these OCI containers to run on embedded devices. There's work that needs to be done there to handle layers efficiently, to be able to have control over how they're extracted, how they're executed, and maybe not have so much requirements on like Python or even Golang, right? Something lightweight in C would be very nice. And so I know the industry is looking for solutions. I don't know if there's necessarily a project or a process that's out there that's defining these things. I think OCI containers or the OCI spec itself would probably be a good place to start there and work backwards. It's something that we at Foundries are pushing very hard for. Obviously, we believe that it makes the application development a lot easier. So we're trying to use those standard specifications and build our platform around it. Hopefully that answers some of your question. I don't think that was a complete answer, but
cool, great, thanks. Another question is, what are you meaning by root of trust?
Yes, so the root of trust. Obviously, in the best case scenario, you have access to the boot ROM, which is effectively the first software that the processor is going to boot. Now, a lot of times, unless you are a really influential SoC vendor in the industry, you probably will never get access to the boot ROM code. So the next thing we do is where that jumps to next, and that's typically what we chain the root of trust to is the SPL. And this is a piece of software, if you think of like an early first stage bootloader, that can bring up basic things. And effectively what this means is you fuse the device. So you burn public key hashes in to the hardware itself, and it will basically instruct the boot ROM to only load software that can be verified using those public key hashes. So it will not load SPLs from anybody else unless it's been signed correctly. And usually the signing keys are owned by the user, and so they're the only ones that can replace that SPL. And that sets the root of trust, because the only thing that boot ROM trusts is the SPL. And then from there, that root of trust is then extended to maybe the second stage bootloader, like UEFI or U-boot, right? And then that uses the chain trust from the SPL to then verify the kernel, and then from the kernel to user space, and then our actualizer client itself, the update client, will continue on that chain of trust and link that all together. So that's what I mean when I say root of trust. It's embedded in the hardware in some ways. Now, fusing it into the hardware is a good way, and then also running an external hardware security element like the SC050. That actually is the better way to do it, because it generates keys inside of a secure element, which nothing can access. Obviously where you store keys, if you don't have a hardware security element, is usually an RPMB, and that's a decent solution. But honestly, if the SoC itself, like a Spectre or Meltdown attack, were to happen, it compromises that SoC, and RPMB could be negated at that point because the SoC is compromised, and you could lose access to those keys. So we recommend for high security applications embedding the root of trust in an actual external hardware security element that you put off chip.
Cool, thank you. Question here about over-the-air updates. Are there any kind of size constraints in what we can do in the over-the-air updates?
Yeah, so we have a few customers that are running on like a Cat 1 narrowband LTE, and obviously keeping the update size small is ideal. So A couple things we're doing, we create static deltas. So instead of having the backend server try to calculate where you need to be, it can calculate that quickly, or it pre-calculates it and gives you the static delta, so you don't have to download more than you need, and that helps optimize the over-the-air updates. Another thing that we're looking at is encrypting the applications. It's not really an optimization for size, but making sure that the applications themselves, the Docker applications, are encrypted when they go over the wire, even though it's going through a TLS channel anyways. That's something that we're looking at. One thing that is a little problematic is when you move to new versions of distribution and the tool chain changes, right? You can't binary diff that, because the diff is going to be completely different. So those are sizable updates, and they need to be planned. And so those are some of the things that we've run into where OTA size becomes an issue when you're upgrading tool chains and things like that, the fundamental technologies. But typically that doesn't happen all that often unless you're really trying to get some sort of optimization from the tool chain, in which case you may have to take a little pain and do a big update. But again, at least from the Foundry Factory perspective, we don't charge you for bandwidth. So if the update is large for some reason, that cost isn't passed on to the customer. It's still fixed price.
Okay, cool, thanks. Now, if anyone's got any other questions, either put them in the chat or the Q&A. I have another question here. What is the normal minimum system size for running?
Yeah, that's a good question. So we can run on platforms, down into probably 256 megs of system RAM on a single core, A5 or something like that, or an A7. You probably want at least a gig of flash. And I say that because, you can trim down the Linux micro platform, fairly small. You could remove Docker if you'd like, so you don't have all of those dependencies to get it down, and you could just do updates to the operating system. But for what we see, a gig is a good, chunk of space that allows you to grow over time, because these updates obviously are going to build over time. So you want to allow yourself, I would say 50% more space than you think you're going to need if you plan on maintaining this for 20 years. And I would say that's at a minimum. The good news is, because of cell phones pushing the technology and making everything bigger and faster, that the flash chips that are larger in size actually are starting to become cheaper. So, it may not be cost effective to even do a 1 gig chip anymore. It might be actually cheaper to do a 2 gig chip. So those are things to consider when you're building that. But again, if you have any particular requirements on a size of device, come talk to us. We can, kind of give you some advice on whether we think that's too small or too big. But typically, or at this point with our Linux micro platform, we don't go anything lower than an A series. So M series processors. There's a potential solution in the future for that, but it will not obviously be based on Linux. It'll be based on something else, probably an RTOS.
Okay, great, thanks. Any other questions at this point in time? If you want to put them either in the chat or in the Q&A area. Give you a few minutes. Thierry. Okay. Question. I've heard that you mentioned an over-the-air framework that does not require A to B management of images. Can you explain what happens then when an update fails?
Yes. Okay, this is a good question. So OS tree is the technology we use for doing the updates. Now you can go read about that. It's obviously open source software, but if you think about it, it's Git for your file system. So every time you make a change to the file system, that could be the kernel binary, that could be user space packages, it will basically create a new commit. And those commits stack on top of each other. And if you were to make a bad commit, let's say that maybe a kernel, you left out a driver or something, and it's going to panic and it's going to reboot on that update. So that update is applied, and so there's a new Git commit. That update comes down, and it's just that Git commit because that's all it's changed. That gets applied, and the device reboots. It loads the new kernel, it boots, and then it fails. It panics or it hangs, and the watchdog resets it. It's going to try by default 3 times. That's the boot counter. And so U-boot's going to increment that it tried to boot that update 3 times. At which point it's going to say, this isn't working. We're going to go to rollback. And what's really neat about rollback, because you don't have AB, right? Obviously, you usually swap a spot and boot the old image. It will actually go back to the last known good commit. So it can basically do, in Git terms, git reset -- hard head L1, right? And that pops the last commit off the stack and will load the previous one. And then that will boot the old kernel that worked. And then it will mark that the update failed, and you'll get notified on the dashboard that the update failed due to the rollback. So that's how it works when you don't have an A/B swap, which is really nice because then the next commit you make that maybe does work, it'll just move to that one, and it will kind of skip the one in between there. And so you can have a bunch of bad updates in a row and still be able to recover because it knows the last known good update OS tree commit hash, if that makes sense.
Good. Thanks. Any other questions? Oh, another question's come through. Do you allow updating the low-level boot software, and does this work with the rollback process you've just described?
Yeah, so we are actually in our next release going to have this working, and it does work in the same way. So this is very, unfortunately, hardware dependent, as you might imagine, because the boot firmware is very hardware dependent. But yeah, so from the hardware perspective, the boot ROM, a lot of these newer designs, but even some of the older ones, will allow you to have two SPLs. And so you can have essentially an A/B slot for the SPLs, and that is a whole boot stack firmware. So, and this is actually the reason why. Let me back up a little bit. So when we're talking about vendor BSPs and updating vendor BSPs, because currently, you ship a BSP and then you forget about it. But what happens if you wanted to update to the next, let's say, NXP BSP? Well, that's great. You can update the kernel, you can update the user space, but there's dependencies on that low-level firmware. So you can't just take those single components and apply them. You have to actually update the entire stack, right? And so we use the same type of process, but it is an A/B process to basically have two boot firmware stacks, and that the boot ROM will check the SPL, in that new updated slot. Try to boot that, try to go through that boot process. If it doesn't work, it will basically try 3 times and then try to reset itself. And so we actually have this working, and I'm giving a presentation at ARM's DevCon, most likely, and potentially Embedded Linux conference on updatable boot firmware, how we do it, and actually give a live demo of being able to do that. So the whole boot stack, you're talking about the SPL, you're talking about the bootloader, you're talking about opte, trusted firmware, all of that stuff will be updated during this process, and it effectively allows you to switch between those two. And if for some reason any piece in that puzzle of the boot firmware stack doesn't work, it will allow the boot ROM to go back to the good known version of the SPL and that boot firmware stack. And what's nice about that is that you can still keep your security, because you can sign both firmware packages themselves with the same key, so that they're trusted by the boot ROM and the underlying hardware. So you can do a secure boot firmware update over the air, and have some confidence that you can roll back from that, and not just worry about completely bricking a device in the field. So that is a good question, as a timely question. We are really excited to talk about it, so I'm glad you asked that. I think I don't think you've heard a peep out of us yet about boot firmware updates, but it's going to be a big thing coming up in the next release, and we're really excited about it. So thanks for asking that.
Cool. So if you've got any more questions, put them on, and if not, we'll close this session. And wait, another one come through. Oh yeah, got another question.
Okay.
About keys. Can you revoke keys?
Yes. So it depends. And when I say it depends, revoking probably isn't the right word. Rotating keys is probably the right word. So it would be, if you go look at the tough spec, there's an entire section on key rotation, and we support it. In fact, the first thing you're supposed to do with a factory, because we create the keys for you, is to rotate them yourself. And so if you go through our getting started guide in a factory, that's the kind of like the second step after you create the factory, is to go and rotate your keys so that you own them, and you understand that process. Now, where I think we're lacking, and this is something that we're actively working on currently, is when you have a hardware security element with keys that are provisioned by the hardware security element, rotating or revoking those keys is not something that we can do today. Now, that's something that we understand is something that needs to be fixed, and we are working with an industry partner, hopefully in the next few months here, to leverage their solution for rotating those keys, and being able to actually rotate keys and apply new keys directly into the hardware security element if you have such a thing on board. Over the air and done remotely. So that will be a huge, I think, benefit to our customers to have that capability. Obviously, it's something that you have to pay for because leveraging a industry partner solution like that, they think there's a lot of value in that. But it does provide a solution for a huge gap when it comes to doing hardware security elements that are being managed remotely on edge devices. So hopefully that answers your question there.
Great, Taylor, thank you very much. I think that's us come to the end of the time. Thank you for your going through this in detail, and I hope everyone's found it useful. We will send out the slides after this, and we'll keep doing more sessions like this through the meetup. So if there's anything in particular you're wanting us to cover, it'd be really useful to let us know. And feel free to get in contact with us if you get any other specific questions. So thanks. Have a great weekend.
Thank you.